Boa noite, comunidade SPE. Como é que vocês estão? Tudo bem? Espero que esteja tudo bem aí com vocês. Hoje a gente está de volta com mais uma Tech Tuesday. E, como de costume, eu inicio aqui a Tech Tuesday falando um pouquinho dos nossos próximos eventos, atualizando todos vocês. Tá? Meu nome é Sérgio Cavalcante, eu sou diretor de eventos da SPE Brasil. Tá? Então, com os próximos eventos, a nossa sessão está planejando uma série de atividades, né, técnicas e profissionais. Mas antes de falar dos eventos em si, eu queria trazer para vocês, falar um pouquinho sobre os comitês técnicos. A SPE Brasil tem uma série de comitês de diferentes disciplinas e com muitos participantes, membros da SPE, que se congregam e trabalham, realizam reuniões, discussões técnicas, eventos, nos diversos temas, tá? Desde reservatórios, a subsea e etc. Tá? Então, estou trazendo aqui para vocês hoje a oportunidade de se afiliarem no Comitê de Offshore Facilities, que é um comitê novo, que está surgindo, e que quem tiver interesse, por gentileza, entre em contato com a SPE Brasil, que a gente direciona vocês para os responsáveis do comitê. Ok, gente? Agora, nosso próximo evento da SPE, a gente chama de SP Day. Né? O SP Day é um evento de gestão da seção SPE Brasil, onde os diretores e os nossos deputies, a gente se reúne e discute as atividades para o próximo ano. Normalmente para o próximo ano, 1 ou 2 anos que seguem. Então, dentre as atividades, a gente discute eventos, os próprios eventos online como esse aqui, como a Tech Tuesday, a gente discute participação dos comitês técnicos, né, em cada um desses eventos. Então é um evento muito importante, é um evento muito bacana, que ajuda a gente a desenhar esse futuro próximo das atividades do SPE. Então, em breve a gente vai ter uma série de resultados do SPD que vocês vão tomar conhecimento, seja via e-mail ou via o próprio SPE Brasil. Agora, em maio, 18 e 19 de maio, a gente tem o prazer de receber no Brasil, no Rio de Janeiro, o Student Symposium regional. Né? Então, a gente está falando aqui de América Latina e Caribe. Então, é um evento que vai reunir estudantes da nossa região, em torno da indústria, das empresas, e dentro desse simpósio, a gente vai ter eventos importantes como o Regional Student Paper Contest, que é uma competição que trata da apresentação da pesquisa de cada estudante, e com a apresentação da pesquisa, alguns jurados eles avaliam essa pesquisa, e a gente ranqueia, e a gente tem essas pesquisas elas são premiadas, né, os primeiros lugares, com viagens e com, inclusive, valores em dinheiro. Então, é muito, muito bacana, é uma competição muito bacana, não só de participar como estudante, como pesquisador, mas também de assistir, né, de estar ali presente nesse momento especial para todos esses pesquisadores. A gente vai ter também o Petrobowl, que é uma espécie de quiz que trata de assuntos da nossa indústria, muito interessante. Times de diversas universidades da América Latina e Caribe participam, então é um clima muito bacana, um clima, a gente percebe ali os estudantes torcendo, cada um por sua universidade, e não se engane, os estudantes que participam, né, do Petrobowl, eles se preparam ao longo de todo o ano para essa competição, e uma vez que conseguem, que realizam ganho regional, viajam para fora para participar do Petrobowl Internacional. Também é um evento muito bacana de participar e assistir, né? Então eu convido a todos, em breve, nas nossas mídias digitais, vocês vão ter acesso aí aos links para se inscreverem e poderem participar do Estudo Simpósio. A gente vai ter uma série de apresentações de representantes da indústria, uma feira de carreira, a ideia é colocar os estudantes em contato, né, com a indústria, e uma exibição, né, uma exhibition das empresas, de suas atividades, suas principais atividades, tá, e de suas necessidades, é claro, né, em termos de recursos humanos, para essa nossa indústria tão importante. Okay? Então, recomendo aí a todos, estudantes especialmente, que gostariam de participar, fiquem atentos à nossa mídia, que vocês vão ter toda a informação necessária para participar junto com a gente. Esse ano, em 2024, o SPA-TCE, a TCE do SPA International, completa 100 anos que esse evento é realizado. O tema vai ser Powering the Future of Energy with a Century of Innovation, e o evento vai acontecer em setembro de 2024. É um evento muito importante para a indústria como um todo, e convido vocês todos a participarem. A gente está com Call for Abstracts aberto ainda, então recomendo que enviem seus abstracts, e quem tiver a oportunidade de viajar para conhecer esse evento, esse ano é um ano muito especial, é um ano muito bacana de estar lá presente, participar e ver todos os acontecimentos. Ok, gente? Bom, falando um pouquinho dos nossos eventos, vamos passar então para o nosso evento principal de hoje. A nossa Tech Tuesday está trazendo Thomas Jorgensen. Ele vai falar sobre Lateral Stimulation Technology for Improving the Connectivity to the Reservoir. E para isso, vamos estar aqui moderando o Pierre Edward, que é o nosso diretor de Relações Internacionais, e eu, Sérgio Cavalcante, vamos estar aqui ao longo da apresentação e no momento logo depois de discussão e Q&A. Ok? Então, agradeço a todos. Pierre, welcome to one more Tech Tuesday, right?
Fantastic. Thank you, Sergio. So welcome, everyone. For those of you who might be watching live, for those of you who will be watching the event after the fact, best wishes for 2024. It will be the first event of the year, and great pleasure to bring you something which we understand will be very shortly brought into Brazil and demonstrated, hopefully, with success in Brazil, and for which I understand, Sergio, you also worked on the concept a few years ago, which is
right.
incidental. But so Thomas Jorgensen with Fishbones has the global responsibility for sales, marketing, and application engineering activities with Fishbone AS in Norway, and he's worked for Fishbone since 2012. Prior to that, Thomas held several technical and business development positions with Weatherford and Halliburton, both in Norway and internationally. He holds an MSc degree in petroleum engineering from the Norwegian's University of Technology and Science, which he got in 2002. He has authored 7 SP papers, and when I saw Thomas' presentation on Fishbones, I thought it was definitely worth sharing with the community in Brazil, the community in Latin America. Generally speaking, there aren't that many new things under the sun so often, and this is I believe a technology for potential relevance and application in Brazil. The floor is yours, Thomas.
Thank you very much, Pierre. Thank you very much for that kind introduction. Good evening, everybody. First, I would like to thank SB Brazil section for the invitation to give this presentation. I'm very pleased to be the first one in 2024, and I hope for a good year for all of us. So today we're going to talk about stimulation. There are many types of stimulations out there. Lateral stimulation technology offers an alternative to those, such as matrix stimulation and fracturing and acid fracturing, and so one can consider the lateral stimulation technology as bridging the gap between matrix stimulation, which is more near wellbore, and fracturing, which extends, potentially hundreds of feet into the formation. Lateral stimulation technology fits right in between there, and has applications in low perm and layered and fractured formations, which we will come back to more in this presentation. So the lateral stimulation technology is a open hole completion and stimulation system. Is deployed as part of the lower completion. So it's run in hole with a liner, and then there are multiple subs spaced out along the open hole section. And there are 3 or 4 tubes which is called needles, that will extend from the subs and into the formation, either in a jetting process or in a drilling process. So with this technology, it's possible to achieve, a couple of hundred laterals in a short pumping job that only takes a few hours. So, with that, I will move on to the next slide for the agenda. So, half of the presentation is about the technology. We'll talk about the jetting stimulation technology and the drilling stimulation technology. And then the second part will be case histories and track record and give some examples from other places in the world from both carbonate and clastic formations. And then there will be a Q&A session after that. So moving on to the lateral stimulation technologies. As mentioned, there are two ways of creating these laterals. It's either in a jetting process or in a drilling process. With the jetting, there are 4 needles per sub, faced 90 degrees. So there will be one lateral going in each in 4 directions, faced 90 degrees, and they will reach about 10 meters away from the wellbore. The needles are extended in a jetting process. Typically, this technology is run in carbonates, so HCl will be pumped. The needles will be pushed out from the subs, and they will jet their way into the formation. And I will shortly show an animation for more details on how this is run. The lateral stimulation technology drilling uses a drilling technique, as per the name. With that technology, there is no bullheading of acid, simply circulation with the rig pump and with the drilling fluid is sufficient. So the circulation of the drilling fluid will activate turbines attached to the back end of the needles. There are drill bits in the front end of the needles, and the needles will drill out at specific rate and pressure regime. So it's a quite effective way of creating additional reservoir connectivity by using only the rig and existing drilling fluid. Both these systems come in two sizes. There is 4.5-inch system for 6-inch open holes and 5.5-inch system for 8.5-inch open holes. In terms of materials, they can be manufactured in any type of material to match the liner specification and tread requirements. So I will run an animation now on the jetting technology to go more into detail on that. I don't think there is time to also do a drilling animation that's available online. But the end result is very much the same with laterals extending out from the subs. So then moving to jetting animation, I will get this going. This shows the sub, which is about 1 meter long, and is made up to a full-length liner joint in a workshop. And then 4 needles are installed into this assembly. Then there are an open hole anchor that will go with the string to anchor the liner in place. And there is an activation shoe that's required. This enables circulation as we run in hole, and it's closed when we start pumping acid. So this liner is run into the hole. Multiple stimulation subs can be run depending on the length of the open hole. There's an open hole anchor being run, and then there are additional subs coming. And the liner is then run to TD. The liner hanger is set. The top hanger is set. And we start pumping acid into the liner. Now the shoe is open, so it's possible to get the acid all the way down to the shoe. and the shoe will close upon contact with acid. There are flapper valves that will close. And now we have a closed system, and sorry, I just have to get this in the right order. Now we have a closed system and can continue to pressure up, and the open hole anchors will expand and anchor the liner, and the needles will activate. So now the needles are activated in a process from dissolution of the carbonate formation and erosion of the formation. So basically the needle make their own hole as they progress forward, and then up to 10 meters away from the wellbore. All the needles activate simultaneously. This is a typical operation that takes 3 to 5 hours to complete the extension of the needles. After needles have been extended, the running tool is pulled out of the hole. And then an optional tool can be run. It's a junk basket with a cutter head to cut and remove any remaining needle tails from the liner ID. This is to make it possible to do an intervention or run PLT later. So this tool cuts and collects the remaining needle tails and bringing them back to surface. An alternative method is to run a flat bottom mill and just to push all the remaining needle tails to the bottom, which can be a bit more effective way of doing this operation. Then the well is put in production. The hydrocarbons will flow in the annulus between the needles and the formation. The jetting creates a hole that is larger than the needle itself, so there's room for fluids to flow down into the main bore and then through production valves in the subs. So this technology makes it possible to connect layers, to connect to fractures, and to get that acid mechanically, diverse and uniformly distributed between the needles, with the objective of increasing productivity or injectivity in case of water injectors. This slide shows a couple of photos of the drilling technology. You can see the sub there to the right, made up to liner joints. The front sub shows a needle sticking out, and you can see the drill bit there in the front. This is a 1/2-inch drill bit sticking out there. This piece will be pushed down against the seal and secured in place before we run in hole. To the left, you can see the needles being assembled and pushed into the made-up subs and prepared. This is all done in a workshop, and then before the ready assemblies are shipped to the rig site. So on the rig, the tools will look like this. To the left here on the pipe deck, you can see the stimulation subs wrapped up in protective material in white on the top there, and we have the full length liner joints and all the needles inside. And in the picture to the right, you can see one of the subs going into the hole. I also would like to mention that it's possible to combine the subs with standalone screens in case of need for sand control. This is a solution that has been run in a number of wells in the North Sea, where instead of placing the sub on a blank joint, it's mounted onto a screen, and then in that case there are no production valves in the sub, but all the inflow will go to the screen, which has to have a non-perforated base pipe and an ICD with a check valve. So the inflow will be to the ICD, and the check valve is required to hold pressure as we are circulating to drill out the needles. This line here shows some core samples, some formation samples. We do testing up front on representative formation samples to make sure that the formation can be penetrated either with jetting or drilling, and the testing also gives a good information on the time, the ROP basically, for to extend the needles. So from this testing that's done up front, we can calculate the volume of acid needed to extend the needles, or the time required to circulate to drill out the needles. So to the left here, you can see a limestone formation that has been jetted, and you can see the hole there. And to the right, there are some sandstone samples. So these are some of the objectives, or the main objectives of deploying lateral stimulation technology. It's about creating more exposure to the reservoir and to connect layered formations and to connect to natural fractures away from the wellbore. It's also possible to connect to any sweet spots and lenses that could have been missed during geosteering with this technology. In terms of the jetting technology, the acid will be uniformly distributed between the needles, as there is a jet nozzle with a small, very restricted ID in the tip. So the acid will distribute between the needles, and you can be sure that the acid will be distributed into that formation 10 meters away from the formation. Given the length of the needles, certainly bypassing the damage zone, and also given the length of the needles, this will provide an accurate type of stimulation. It's fully controlled. In case of a thin formation, it's possible to reduce the length of the needles to ensure that they stay within the target formation. Another benefit of lateral stimulation or any type of stimulation is that it's possible to produce the well with a lower drawdown, and then there will be less coning. And I will show an example on that in one of the case histories coming up soon. And it's also possible to reduce the CO2 footprint. A study was done by a third party in Norway a couple of years ago that looked at like a standard North Sea well, like a 1,000-meter horizontal well, and calculated the CO2 emissions from hydraulic fracturing operations and from a lateral stimulation operation. And that concluded that it's possible to reduce the CO2 emissions from the stimulation operation by 95% using the lateral stimulation technology. Main reasons for that is reduced rig time and the elimination of the stimulation vessel. Moving over to the track record and case histories part of this presentation. This map here shows where the lateral stimulation has been deployed to date. Those countries are colored in green. Starting to the left, in the Western Hemisphere, there are deployments in the United States and in Mexico, both onshore and offshore in those markets. We have the North Sea market in Europe, Middle East. Those carbonates, naturally fractured and layered carbonates, are very good candidates for this type of technology. Then you have India, deployments in carbonates there offshore, and in China, sandstone onshore and basement formation offshore, and also one deployment of the technology in Indonesia. And there are some countries coming up, and as Pierre mentioned, we are preparing for first deployment in Brazil, and a few other countries are colored in yellow with upcoming installations. As mentioned in the beginning, this technology is applicable in a whole range of applications. This is a summary of what has been done to date. I mentioned naturally fractured carbonates, layered carbonates. There are deployments in chalk formations. with the drilling technology, deployments in layered sandstone and fractured basement, and also in conglomerate formation. And there is one deployment of the jetting technology in coal bed methane. In terms of well types, it's really applicable in any kind of well. To date, there are deployments in oil and gas producers, water injectors, exploration, and appraisal wells. And to the right there, you can see a combination with other well construction technologies that has been performed to date. As of today, there are 44 installations of this technology globally. Installation number 45 is ongoing, and it will be a busy year in 2024 for our operations team, with multiple installations in the planning. Both onshore and offshore wells, you can see the split there is almost 50-50. In terms of biggest job, 61 subs. That is a deployment in the North Sea in the 2,600 meter horizontal wellbore. Deepest deployment, 5,500 meter, and that's also the warmest application, 190 degrees C. This does not represent the limits, but the actual installations so far. Then I have selected a number of case histories to give an idea of various applications and the type of results that have been achieved with the lateral stimulation technology. And starting off with like a typical Middle East carbonate application, low permeability limestone, less than 1 millidarcy horizontal permeability, and there's some denser layers with even lower permeabilities and quite poor vertical permeability. These wells are typically metric stimulated on coil tubing. The operator here wanted to test the lateral stimulation technology to see if better results could be achieved. So this specific installation took place in a new well with a 1,500 meter horizontal wellbore. 6-inch open hole, a 4.5-inch system was deployed with 40 jetting subs evenly spaced out. And since there are 4 needles per sub, there are 160 needles or laterals were made. In terms of results, the initial production testing showed a 300% uplift compared to offset wells, and the long-term production has been really good. There are 2 SPE papers written and published by the operator. And this slide here is from one of the SPE paper presentations. To the left here in this image, you can see the 3 wells, the one in the middle with the lateral stimulation technology, and 2 offset wells that were matrix stimulated. In the chart to the left, there is a comparison between the lateral stimulation completed well, which was producing 1,600 barrels per day, and the 2 offset wells, which were at 500 or even less barrels per day. And to the right, in the chart to the right, you can see the PI difference. Moving to also another Middle East installation. This is offshore in a multi-layered naturally fractured limestone formation. This well was targeting 3 layers called the D1, D3, and D4. Layer D1 has quite good properties, and no stimulation was performed in that. While in the lower 2 layers, stimulation was needed. The operator evaluated different stimulation methods and decided on the lateral stimulation technology. The permeability in the lower 2 layers is quite low. It's like 0.2, 0.3 millidarcy. 20 jetting subs were deployed across the lower 2 layers. and the jetting operation was completed. The well was put on production, and with a much higher rate than expected. So the operator decided to run a PLT to confirm where the production was coming from. And that PLT confirmed that the majority of the production was coming from the lower two sections with a 10 times higher than expected rate. So this well achieved a 3-well production plan, and no ESP was required as planned in this well. So a good installation of this technology offshore Middle East. Another one from the Middle East, this is onshore, and this is an example where lateral stimulation technology makes it possible to produce a well at a lower drawdown to avoid coning. This was an existing well that suffered from high GOR since the operator had to produce the well at a very high drawdown, given this very tight formation. So stimulation was needed. Lateral stimulation technology was deployed. A 4.5-inch liner with 40 subs were run with 2 different needle lengths to avoid stimulating into the lower zone. The well was put on production with a 4.5 times increase in PI, which allowed the operator to reduce the drawdown and also reduce the GOR. So the objectives of these installations were met. Moving from the Middle East to Asia, this well is an appraisal well. This was the final appraisal well in this offshore limestone formation drilled in 2022. The previous appraisal wells were stimulated in a bullheading operation, matrix stimulation, and they didn't really achieve the results they were after. They were targeting 600 barrels per day from these appraisal wells. So it was decided to run the lateral stimulation technology in the final appraisal well. A quite small system with only 6 subs were run across the target lower layers. The deployment was executed, the pumping was done, and the well was production tested. Started to flow more than 2,000 barrels per day. It sustained at 1,800 barrels per day during the production testing. So the production target was met, and the operator is proceeding with the field development plans. Then we're moving to Mexico. This is another offshore limestone application where wells typically are matrix stimulated in a bullhead operation. And as you can see in this schematic to the right here, there is a hyper fractured formation on top. So one can expect that most of the acid that's pumped in such stimulation operation is going into that formation. So uniform stimulation would be difficult. In this well, lateral stimulation technology was deployed in order to achieve a more uniform stimulation of that reservoir. So a 4.5-inch system was deployed. 20 jetting subs were run, making 104 laterals. The well was put on production, rates pretty much in line with expectations, and the results long term has been that this well is sustaining rates in a much better way than the offset wells. So this well, as far as we know now, is the best performing in the field, and also producing at a lower water cut. One more limestone application from the Middle East here. I wanted to show a example where a PLT was run, and with in a bit higher permeability application than the other ones I have shown. This is an offshore limestone again, with a 900 meter open hole section and a system with 10 jetting subs where was installed in order to improve on the productivity compared to matrix stimulation. So this installation was executed, acid was pumped, and the well put on production at 150% increase in PI. And the PLT showed a uniform influx throughout the horizontal, and there's an IPTC paper written on this case. And this slide here is taken from from that paper presentation, showing the PIs. Normally, reservoir modeling is done up front to get an estimate on what an open hole well will produce and what the well could produce with a lateral stimulation installed. In this case, a 40% improvement in PI was expected. From the PLT, 100% was confirmed, and from pressure buildup, 150% increase in PI was achieved. Another limestone installation. This is one of the tighter formations this technology has been installed in 0.1 millidarcy formation, layered heterogeneous formation onshore North Africa. Previous wells and offset wells had been hydraulically fractured, and one of the challenge here is that the lower formation is water saturated. As I did mention that formation on testing on core samples is done as part of the planning. That was also done in this case, and also formation samples from the lower zone below was provided, and it was confirmed that jetting would not happen. That formation was too dense for the laterals to be made. So in this case, we could be sure to not stimulate into that water saturated formation. In terms of results, this will achieve 150% the expected rates without any water. So those were the jetting examples. I have selected two case histories for the drilling technology as well. Starting with a sandstone application in the Norwegian Sea, targeting a low perm and layered 30-meter thick sandstone formation, which has some impermeable stringers. And the objective of the lateral stimulation technology was to penetrate those impermeable stringers to be able to drain from the whole sand reservoir. This well, let me go to the next slide, was a dual lateral well, or is a dual lateral well, with the lateral stimulation technology deployed in the main bore. That open hole section is 2,000 meter long. And then a lateral was drilled, also 2,000 meter long, at the same TVD, same sand. And from the logging, the operator expected the contribution from these two boreholes to be the same. The lateral was completed with pre-drilled liner, so no stimulation was deployed there. So going back to this slide, this schematic here then shows the completion in the main bore with the lateral stimulation technology. 48 subs were deployed, creating 144 laterals in a 7-hour pumping operation. So basically, a low solids oil-based mud was circulated for 7 hours to extend the needles in this formation. The well came online end of 2015. After 2 years, Equinor, the operator, ran a production log below the junction, so to measure the contribution from each of the branches. And that PLT concluded that 2/3 was coming from the main bore with the lateral stimulation technology, and 1/3 from the lateral. So 100% higher production from the main bore with the lateral stimulation technology. One more well has been installed in this small field development, which now has 2 production wells, and both of these wells are still producing. The final case history is also from Norway. This is from a field in the North Sea, so a bit further to the south, offshore Norway, where lateral stimulation technology was deployed in 2 wells in an infill well campaign in 2021 in the Edvard Grieg field, which has a conventional sandstone reservoir on top here. But below there is a fractured and layered conglomerate formation, and this conglomerate was the target for this infill well campaign. This conglomerate has a consolidated sandstone with rocks embedded. So those rocks are of granite, really hard to drill. So a special drill bit design was developed together with the operator for this application. Given the unconsolidated sand, there was a need for sand control. So the lateral stimulation technology was combined with standalone screens and ICDs with check valves in these completions. There were some faults that led to losses, which were isolated with swell packers on the completion string. So in the first well, 53 subs were installed, creating 159 laterals. A second well was drilled a few months later. That contained 61 subs, and that is the record installation to date. That was a very long horizontal well bore, 2,600 meters. The first well was reported to produce at 10 times higher productivity than expected. There is an SPE paper written on these 2 wells, and a third well was completed in this formation in August last year. Following the first well coming on stream, the operator, which was Lundin Energy at the time, they have been taken over by Aker BP since. They made this announcement on their website. So this is basically a copy paste from that website, presenting the project, targeting the conglomerate formation, and with the installation of the lateral stimulation technologies and the results. And a few months after, the operator announced that based on the results from this infill well campaign, they were able to increase the recoverable reserves in the Edvard Grieg field by 17%. So that concludes my presentation, and I'm happy to move over to the Q&A session.
Fantastic. Thomas, thank you for the presentation, and I'm sure the audience will have some questions. I certainly have some. Sergio, I don't know if you have any, but it's the second time I see your presentation, Thomas, and I have new questions after that. So would you mind if I can start? Would you mind retracing for attendees, the audience, the flow path of the fluid and what happens to it through the needles, etc., potential returns. And there was one question from the audience about the typical OD of the needles themselves, which are made of titanium. You might want to
right.
mention that again.
Yeah, so the flow path is in the annulus between the drilled or jetted needle, and so there's an annulus, outside the needle to flow back into the main bore. Maybe I can bring up the very first slide to, and hopefully you can still see the screen, right? So the inflow would be on the outside of the needle, between the needle and the formation, and into the main bore, and then through production valves in the sub, or through the screen and ICD in case of a sand control application. The flow through the needle itself will be very restricted because of the small diameter of the jet nozzle. So we consider the outside the primary flow path.
Great, Thomas.
As for the needle itself, the OD is 8 millimeter.
Yeah, I have a quick question also, if you allow me, related to the needles. You've shown that there is a tool that allows us to remove the excess of needles that stays in the borehole. And my question is related to as you install the needles and you start producing or injecting into the oil, have you guys evaluated the effect of the presence of the needle to that inflow? Because the inflow into the needle is restricted to that area related to the 8 millimeters diameter of each needle, right? If you didn't have the needle there, or if you were able to somehow dissolve that needle later, you would actually increase that inflow. Have you guys evaluated that somehow?
Are you now talking about the needle inside the lateral?
The needle inside the lateral, yes.
Yes. So typically there are many needles installed. So if you take the total production and divide per needle, the flow is actually quite small. There has been some CFD modeling done on this, and that concluded that for normal wells, we do not see any pressure drop of significance. So there is modeling, but there can be case-specific modeling done if needed for very high rate wells.
I see. Great, thank you.
Yeah.
We have another question from one of the attendees, and I think it's a good one, very legitimate. Have you had issues during deployment or during the activation? And if you have faced some issues, what have been potential mitigations or solutions?
All right. Yes, we have had some issues, especially in the early days. Bringing this technology into the market, and there has been some lessons learned, especially on the acid capability. We had a big lesson learned in one well. We are dependent on reaction between the shoe and the acid in order to close the shoe. And 10 years ago, we didn't have the QA/QC procedures that we have in place now to qualify the acid. And we have one well where the shoe didn't close and the acid was pumped out to the shoe and not to the needles, and there was no jetting. So that was a big lessons learned. Now there is thorough testing of the acid during well planning, and there is also testing on the acid on location before it's pumped, to ensure the 100% capability and that the job will be successful. Yeah, I think that's one example of a lesson learned. There has been some other minor issues. One with some galvanic corrosion in some of the tools, which has been rectified by isolating various metals from each other. This was not detrimental to the installations, but obviously not something we wanted to happen, and it's not happened since materials were isolated.
Great, Great, Thomas. We have another question from the audience. It is related to Ricardo Abud. He asked if we have case histories where the deployment of the LST has resulted in increase on recovery of hydrocarbon reserves. And with that, I would like to ask if you did have that case of increase in reserves, and also if you could actually compare results with hydraulic fracture, right?
Right. Well, the best reference would be the last case history that are presented, where the operator concluded on a 17% increase in reserves. In terms of comparing to hydraulic fracturing, there has been some work done by a third party in wells in North Africa, where conclusion was that the LST is the best performing, comparing to offset wells which were hydraulically fractured. There are not too many examples of this. Most of the deployments of the technology is either in wells that wouldn't be stimulated with other technologies, or maybe matrix stimulation would be done in carbonates. So there are not too many direct comparison with hydraulic fracturing in many applications.
Thank you.
If I can have a comment on this, I would. When I saw your presentation again, Thomas, I was thinking, and I told you I'd have a specific interest in sidetracking applications where the reach can potentially be limited. You might have issues placing a lateral in one specific area of a field, pneumatic oil, etc., where if you were constrained geometrically by the wellbore and you weren't in any good position to perform fracturing because of constraints, issues growing out of zone or stimulating into unwanted fluids, then your technology offers an interesting approach, because you geometrically control where the stimulation extends. So I think that's interesting. And then, Sergio, if you worked on modeling the inflow performance brought forward potentially by the technology, does that kind of make sense to you? And if you had to say, or maybe for both of you, a question or comment on the kind of improved performance we could expect from such an application of fish bones, twice, double the PI, or something like that? What's a rule of thumb?
In my research, at that time, a few years ago, when I run a few simulations on fish bones. My results showed that the technology, exactly as you said, it allows you to control your stimulation. So it's how can I say? It's predictable, much more predictable than the hydraulic fracture, right? So that's already an advantage. And we also observed that the technology would benefit a lot reservoirs that are heterogeneous, and especially if they do have connected network of fractures.
Sure.
That would be also a game changer for the technology, because let's suppose that you have your well and for some reason you didn't touch many fractures or many connected fractures. When you have that kind of technology that allows you to actually cross those fracture planes being connected, you actually your drawdown reaches greater area, greater volume in your reservoir. So in that actually increases your production. I would say, I don't have the numbers yet, I don't remember, but for that example that I've worked, I can tell you it was about like 8 to 10 times. Thomas can correct me. I don't remember very well. It's a few years ago, but yeah, it seemed promising when I studied. So Thomas, if you want to complement on that.
No, I think you had a good response there, Sergio. So, it's okay.
On your second case study, Thomas, I thought what you presented is along the lines of what you just mentioned, Sergio. Because if you have multi-layered reservoir, you don't necessarily know in which one to steer the drain. So you can't really predict the performance of and the PI you're going to expect per foot that you drill. So you don't necessarily know which one you want to have the longest exposure to, and having the option to then statistically extend your well bore, and potentially with from a probability standpoint, you will connect to secondary permeability at one point. So
and that's one more important point here on the application of that technology. If I remember well, it was much more applicable to horizontal wells or directional vertical wells that are in thick reservoirs, right? Because then you have space to actually apply the technology and benefit from it. Am I right, Thomas?
Yeah, yes, you are right. So most of the deployments and the most uplift is seen in horizontal or highly deviated wells, and the reservoir should not be too thin. So you can get the benefit from the full extension of the needles.
There's one more question from the audience, if you allow me. Ricardo Abud is asking, what if the operator needs to run a PLT or log into the well after the deployment of the LST? What needs to be done? Would that be easy?
Yeah, so PLT has been run in multiple wells after the stimulation. The only requirement is that the needle tails will have to be removed to have access to the wellbore. So they can be removed with the basket that I showed, the fish basket, which is run through the liner and it cuts and collects the remaining needle tails. Or the needles can simply be pushed to bottom with a flat bottom mill. That is for the jetting. For the drilling, it's a little bit more complicated. Then we have the turbines, so we cannot run the basket directly. The turbines will have to be dissolved. So there are the dissolvable turbines available. Can be dissolved in different types of fluids. And then we are back to the same scenario as with the jetting with the needle tails, which can be cut with the basket. So that so as long as that operation is done, PLT can be deployed, and it has been deployed following such installations.
Great. Thank you.
I think we're nearing the 1 hour mark for our event. So it's maybe time for one tricky question for you, Thomas, and it won't be too complicated. Why not the UK? What has prevented you from breaking into the UK market?
That's a very good question, Pierre, and we're also asking ourselves what we can do. We are actually hosting a one-day seminar. So for those in the UK who are interested to come and learn more about the technology and get updates, hopefully you will sign up for that seminar in April, where we will address the UK market. But historically, I don't know. We just haven't had enough focus on it. We have prioritized other markets. But time will change. It will happen in UK, hopefully too.
Start hopefully with a success case in Brazil, and then continue building in the country. It has plenty of potential. Latin America also.
That's right.
Good luck with that. So, Thomas, you are in Rio at the moment. So if anybody from the audience or listening later today or tomorrow or whatever, absolutely wants an occasion to meet you, they can do that and get in touch with you in the following days. You're in Brazil.
Yes, absolutely. Yep. Very pleased to be in Rio, and hopefully we'll see some of you there.
Great, Thomas. Thank you very much. If you want to, after the event, share your email in the comments section of YouTube, feel free. And then I'm sure we have many questions for the audience that we couldn't address, but I'm sure that I might be able to get in touch with those and answer those questions, okay? And I'd like to thank you very much for your presentation. It's always a great experience in having. I also thank Pierre one more time because he's bringing a lot of excellent presentation. He's doing a pretty good job as our international relations director, right, Pierre? So you're putting us in touch with the rest of the world in terms of technology and all of the news, the technical news that we have all around. Thank you very much, Pierre. Great
So
to be here again with you. Thank you. Okay, so as last words, I'd like to thank everyone who's watching. We are here with us right now. And please, if you need any more information and technical information, please get in touch with SP Brazil section. We're more than happy to help you. And don't forget to become a member of SP, right? That's really important, and that shows that allows us actually to work and do more, collaborate more with that industry in all the regions where we have our work. Okay. Thank you very much. Thank you, Thomas. Thank you, Pierre. See you next time. Go ahead,
and
Pierre.
and a word for our wonderful support, backstage team also
Oh,
helping
yeah.
us make these events possible. So thank you,
Sure.
Jan.
Thank you, Jan. Yeah. Sure. Thank you very much, guys.